Certainly.
Let us know what you want.
Jovan, Jovan Hutton Pulitzer. I am an inventor and pattern recognition expert. I'm also part of the Gold Institute of International Strategy out of Washington, D.C. So to understand what I'm going to talk about today, even though I'm a technology guy, my goal is to make it really simple, really obvious. I'm not going to be talking about codes on machines, how things are swapped, server overseas. I'm just going to show you the simple basis of what possibly went on, but most importantly, how this is fixed, how it's detected, fixed, and will never happen again. And that basically is based on my technology background for over the last 30 years. Just so you have a little basis in it, the fact that your phone now can scan a barcode in any grocery store or any kind of code, or in fact you hear Q codes here today, any type of machine readable code as it talks to the internet, that's my technology. It's a basis of my patent portfolio of about 200 patents on that particular one. My patents are so prolific in licensing that every manufacturer in the world basically licenses my patents to use on any mobile device except one, Huawei out of China. They don't license it, they just use it. And I'm on approximately about 12 billion devices globally. And that's what I'm going to be talking about today, keeping it simple. What could have happened here? How can it be detected and confirmed? And then how can this whole be plugged from now on? Because this is about vote verification. It's 3 Ps that I'm going to deal with today. First, the people. Second, paper. And 3, protection. That's all this is about. So if we'll go on the next slide, if you just roll up for me, I want to kind of show you what I'm talking about when I talk about kinematic artifacts. Kinematic is just a nerdy word for evidence on paper. When 2 physical forces come together, right, and a paper is bent, there's always going to be an example of that. All of us have dealt with this. Machines have very hard, strict rules. You can go to the bank, you can use your debit card. If you put in your PIN wrong, it kicks it back. It keeps asking you, no, correct this, no, correct this. Now you know your money's there, but if you enter your PIN wrong, it won't work. Same thing with your password for your email. So machines have very, very hard rules. A lot of those rules are also in the physical world. So before anything became a rule of a machine, it became a rule in the physical world. That means somebody's hand put it in. In this case, it's paper. What I'm going to be talking about is kinematic artifacts. That's the fold that's left over. You take a brand new dollar bill and you fold it. That fold will always be there. Go to a coin machine and a snack machine, trying to get a snack out of it and put in your dollar bill and it kicks it back. It's the machine saying, something's not right about this dollar. It's broken, it's messed up, the color's not right. We have all experienced this before. What I'm going to be talking about is kinematic artifacts. If we'll move on to the next PDF, please. I'm going to show you how my process of our team, what we're going to do, and if we can enlarge that, that'd be great, is we can detect what I'm calling the counterfeit. There is nothing new that I'm going to be sharing with you today. This is how counterfeit bills are detected. This is how counterfeit art is detected. This has already been adjudicated. It's not new science. It's just never been applied to these very important things in our process. It's about the people. The people want confidence that their vote matters, period. I personally do not care how this comes down, but I do care about the vote being counted and the vote mattering. Whatever our system can detect, and that's what we're here to do, is offer something that can remedy this immediately, the numbers will speak for themselves. The people need that confidence. We need to give the people of Georgia that confidence. But this is not about Georgia. The United States is watching. And this is also not about the United States. The entire world is watching this process. You know, people come, when I was coming in here to Georgia last night, yes, sir.
Mr. Bolton, let me ask you a question. You talk about counterfeit. If we were able to get our hands on those...
Senator Beach, can you speak into the microphone so people can hear you?
Can you hear me?
Yes, sir.
Okay. Mr. Pulitzer, thank you for testifying.
Thank you.
If you were able to take counterfeit, if you were able to get your hands on the State Farm Arena absentee, on the ballots that were run between 10:30 and 1:30 in the morning, would you be able to tell if they were folded, and would you be able to tell if they were counterfeit?
We would be able to tell if they were folded, if they were counterfeit, whether they were filled out by a human hand, whether they were printed by a machine, whether they were batch fed continually over and over. We can detect every bit of that.
Thank you.
Certainly. And so coming here last night, I drove in, the driver from Uber, his fellow name was Christopher. He was Nigerian. He came here to start a business. He's been here 5 years. He legally immigrated here. His brother came first, and he's hoping for his next 2 sisters to come. And his whole goal is to start a tire company because it's about capitalism for him. He says, I want my own business. He was a lecturer on economics in Nigeria, but he came here because he wanted what we had here in the United States and in the state of Georgia. Opportunity, right? But more importantly, if you look at the people that come to this country, it's not just about opportunity and freedoms. They are coming to our country from countries that have one additional thing. They come from countries where their votes don't matter, where their votes mean nothing. And they know here in the United States what we're supposed to stand for is votes matter. Your voice, one voice matter. And so that little bitty piece of paper that we're all talking about here, the ballot, it got chosen too. It was a generic piece of paper, and one day it comes out in a system, it's a ballot. However, when that ballot is filled in by a voter, it becomes a historical artifact. It is what changes that very simple piece of paper into something that can change or guide a nation. And so we have to look at these artifacts. We have to look at this documentation of what the one person expressed in their intent. And so we're getting confused in machines. Let's just talk about that piece of paper, because it's about voter intent. And if there are problems, if there are issues in machines, if there are counterfeits, everybody wants them detected, because at the core of this is each vote must count. Let me show you what a kinematic artifact is. It stands to reason that in an election that comes down to the propensity of a tremendous amount of mail-in ballots, that a very simple process occurred. That piece of paper should have been folded and sent to you at home. A printer prints it out. That printer folds it. It goes into an envelope. It's tracked in the process. United States Post Office sends it out. That is tracked. It comes to your home. You receive it. You open it up. Chances are you didn't vote right then. You kind of put it off a little bit. You opened it 2 or 3 times. You finally got around to it. You put your pen to it. Folded it back, put it in an envelope, and sent it back. That entire process is a folding and rolling process. Every time that piece of paper is opened and refolded, it's like a hinge. Remember, a paper is nothing but a reconstituted tree. So it's constantly breaking fibers. It is actually changing that piece of paper into something else that it can never be hidden once it's done. This is what's called a kinematic artifact. So what you're looking at on the screen is just a simple fold. Looking at it through a computer, the things the human eyes can't see. But if you look at this, you can see even the paper on the front side of the fold to the back side of the fold changes frequency. It becomes a whole different level of light frequency. If you look at the bottom, on the left, you're looking at an oval filled out by a machine. The 2 on the right are by human hands. The first one, that's somebody who fills in a circular motion. Handwriting is the opposite of a rocket. Rockets take off, impact. Handwriting is impact, and then you're filling in that circle, and no matter how creative or non-creative you are, your mind goes, oh, I'm finished with that. But that finish process happens in your brain first, pen second. And so you always start to lighten the load. And so those little bitty light areas you're seeing is the load being lightened by the person's hands. The second one is actually a gel pen. If you look at the one on the left, that's done by a machine. A machine can never hide that it was a machine. Can't. Because the same process of printing the ballot is the same process of printing the vote. Is there another page in this slide? Let's look at these a little bit closer in it. Go on to the next one, please. You can roll them up. So keep on going. So you're looking at 4 forms of human dynamic. First, we want to know where these things mailed. That's the definition of a mail-in ballot. Second, we're supposed to vote for them individually by person and hand. If you have a machine one in there, you didn't cast it by hand. You're looking at the 4 different types. Every pen has a signature. Every ink has a forensic signature. Every hand has a different stroke. You're looking at circular, scribbler, right? Inside out, gel, and Sharpie. Now let's go up to the next one, please. Those, keep it, no, other direction. Thank you. Keep on going. Now look at the bottom in the machine. If you're looking at it, you can see the difference between the two. The handwritten one, the ink is over the paper. Look at the bottom one. That's a machine filling in an oval, and that's a machine filling in a scribble. But you can still see through it. You see all the little bitty dots? That's because the machine still prints the same exact way, just a little denser. It can always be detected. And unless the ballots all had original scribbles, that scribble can be detected. Every time that scribble shows up, we find it, we map it, and all of a sudden, if you have 50 of these scribbles, or even if you have 2, you technically have a problem. We'll go to the next part of the slide, next presentation, please.